You walked into that room, and you stopped. You stood there for a moment, searching, and nothing came. So you walked back out. Most people call that just getting older. But here's what the research actually shows. That moment has nothing to do with your age. It has to do with a single molecule inside your brain. And when that molecule starts to drop, your ability to record and retrieve memories drops with it. The good news? That molecule can be supported. And the science behind how to do it is more advanced than most people realize. Your brain runs on signals. Every time you form a memory, meeting someone, learning something, experiencing something meaningful, a tiny pulse of energy arranges a cluster of cells and proteins into a structure. That structure is the memory. And every time you recall that memory, a pulse of energy activates it. The molecule responsible for carrying that energy through your brain is called acetylcholine. It's a neurotransmitter, and it's directly responsible for your ability to focus, learn, and retrieve memories on demand. Here's the problem. According to research from Vanderbilt University, acetylcholine levels naturally decline with age. By the time the average person reaches their mid-60s, levels can drop by as much as 50%. 50%. That's not a small fluctuation. That's the difference between a mind that fires clearly and one that gropes through fog. And the conventional health world largely ignores it. Most people are told to do crossword puzzles, eat more fish, sleep better. Those things aren't wrong, but they don't address the actual mechanism. The research does. To support acetylcholine, your brain needs a specific precursor molecule called acetylcholine. Acetylcholine is a naturally occurring compound. Your liver produces it. It travels to the brain, where it combines with oxygen to help build and maintain acetylcholine levels. The research on acetylcholine is some of the most consistent in nutritional neuroscience. In a randomized, double-blind, placebo-controlled trial, the gold standard in clinical research, 100 men and women between the ages of 50 and 85 were given either acetylcholine or a placebo for 12 weeks. The group taking acetylcholine showed significantly greater improvements in episodic memory compared to placebo, and composite memory scores improved nearly 5 times more than the control group. Not after years, after 12 weeks. But here's a detail most people miss. Not all acetylcholine is equal. The form that matters, the one with over 50 clinical studies behind it specifically, is called cognizin. Research suggests it may be safe and potentially beneficial for supporting memory function in the context of age-related cognitive changes. And cognizin has something most acetylcholine forms don't: a documented ability to cross the blood-brain barrier efficiently, so it actually reaches the tissue where it needs to work. Now, there's a second compound that works alongside acetylcholine in a way that multiplies the effect. It's called huperzine A. Huperzine A inhibits the enzyme acetylcholinesterase, the enzyme responsible for breaking down acetylcholine in the brain. By blocking that breakdown, it allows acetylcholine levels to remain elevated for longer. Think of it this way. Acetylcholine helps your brain build more acetylcholine. Huperzine A helps your brain keep it. A double-blind clinical trial on 120 patients with age-associated memory impairment showed an effective rate of 68% in the huperzine A group, compared to 26% in the control group. Together, these two compounds address the acetylcholine pathway from 2 different directions simultaneously. But the research goes further. Because acetylcholine doesn't work in isolation, brain function depends on blood flow, on antioxidant protection, on the health of the neurons themselves. That's where a set of well-studied botanicals comes in. Bacopa monnieri, used for centuries in traditional medicine, and now backed by modern trials showing improvements in learning and memory retention, particularly in older adults. Rhodiola rosea, an adaptogen from Siberia, studied for its effects on mental fatigue, focus, and cognitive resilience under stress. Ginkgo biloba, one of the most researched plants in the world for cognitive support, with consistent evidence for its role in brain circulation and memory clarity. Phosphatidylserine, a phospholipid that forms part of the structure of every brain cell membrane, shown in research to support cognitive function and memory in aging adults. Each of these compounds supports the environment in which acetylcholine does its work. Better blood flow, less oxidative stress, healthier neurons. The difference between addressing one pathway and addressing the full system is significant. Memory decline is not inevitable. It's not a fixed destination. It's a process, and the research now shows it's a process that can be meaningfully supported. The acetylcholine pathway is real. The science behind citicoline and huperzine A is peer-reviewed, published, and replicable. And the supporting botanicals in this space have decades of research behind them. If you want to go deeper and look at a formulation that actually brings these compounds together in one place, the link in the description is worth your time. If this kind of research matters to you, subscribe, because most people never hear this side of the story. And they should.